Chromebook and earbuds. If you have your Chromebook today, that's good because you could possibly use it today because I promised Colin that I would show him the shortcut today. Okay? And the shortcut is actually on your Chromebook. Okay? Right? Okay? So, Chromebook and earbuds tomorrow. I'm not here. I'm going to state volleyball this afternoon to watch. And then, so tomorrow you're going to watch a video of 3 examples. It's from last year's class. I would have tweaked the examples, but they would have been the exact same kind. And so I just said, instead of making new ones, I was lazy, and I said, you're just going to watch last year's video. But they asked good questions in it, so that's why I kind of wanted to use that one too, because it's me teaching last year's class. It's only like 16 minutes, and then you got the rest of the time to work on homework, okay? Because you got 4 homeworks due on Monday. Okay? One thing, and I'll have the sub remind you of this tomorrow. One thing is, at the end of the video, there's the homework page like you normally see up on mine, but the days are different because last year's class, so ignore the due dates and stuff on it and the formative stuff on it because last class was set up differently. So okay? All right? Any homework questions from last night from the 5.6 day 1 book assignment ones? Yeah. 21. Six x cubed plus 25x squared plus 16x minus 15. Yeah. Okay. There it is. Okay. So my list, first I got to come up with my list, right? Okay. So my list is going to be 1, 3, 5, and 15. Then I got to go by 2, 1/2, 3 halves, 5 halves, 15 halves. Then I got to go by 3, 1/3, 1, 5/3, and 5. Then I got to go by 6, 1/6. 3 divided by 6 is 1/2. I already have that one. 5/6. 15 divided by 6 is 5 halves. I already have that one. So there's my list. So it narrowed it down, yes, but it narrowed it down to 24 possible ones. Okay? All right? So then you just got to start trying. Okay? I'm going to start trying with -3. 6, 25, 16, -15. Now the reason that I started with -3 was because I used the shortcut. Okay? And I'll teach you the shortcut in about 3 minutes. Okay. All right? 6, -18, 7, -21, -5, 15, and 0. So f of x then can be written as x plus 3 times 6x squared plus 7x minus 5. So f of x is x plus 3, and man, I hope that's factorable. I always start with 2 and 3. I'm going to go with 1 and 5, positive and negative. Because then I get positive 10x on the outside, negative 3x on the inside. Those add together to be positive 7x. Okay? Then from there, x plus 3 equals 0, x equals negative 3, 2x minus 1 equals 0, 2x equals 1, x is a half, 3x plus 5 equals 0, 3x equals negative 5, x is negative 5/3. So my zeros are negative 3, positive 1/2, and negative 5/3. Yeah. Good. Too bad nobody else wrote that down. You know why? Because what was that? 1, 2... That was a sixth of their homework last night. So if they would have written it down, they would have had one of their homework problems done. That would have been one less problem you would have had to do Sunday night, Colin.
Oh my God, it's Monday night.
Okay.
Hmm?
Sure. Yeah. Great warm-up problem for you. I'd like you to do it at this time. Go for it. So the first thing is I need to find the factors of 3. Factors of 3 are 1 and 3. Then I need to find the factors of 2. 1 and 2. So my list of possible real zeros is plus or minus 1, plus or minus 3, plus or minus 1/2, plus or minus 3/2. Okay, that's my list. That was the first answer to the first question. List the possible zeros of f of x. Boom, listed it. Okay? Then, now it says, let's go find one. Anybody find one? What'd you find? 3. Okay. So let's try 3 in 2, negative 5, negative 4, and 3. 2, 6, 1, 3, negative 1, negative 3, 0. Okay? So f of x can now be written as x minus 3 times 2x squared plus x minus 1. Is 2x squared plus x minus 1, is that factorable? Yes, that is. So f of x here could be x minus 3 times 2x, x, 1 and 1. I want positive there, negative there. That then allows me to say x minus 3 equals 0, so x equals 3 is a 0. 2x minus 1 equals 0, so 2x equals 1, so x equals 1/2 is a 0. X plus 1 equals 0, x equals negative 1 is a 0. So the 3 zeros are negative 1, 1/2, and positive 3. Okay. Now, if you didn't see that 2x squared plus x minus 1, this right here, if you did not see that that was factorable, then your choice is the quadratic formula for that. So then you would have said 2x squared plus x minus 1 equals 0. And you would have said that x then is equal to negative 1 plus minus the square root of 1 squared minus 4 times 2 times negative 1 all over 2 times 2. 1 squared is 1. 4 times 2 times negative 1 is negative 8. 1 minus negative 8 is 1 plus 8, which is 9. And that is, the square root of 9 is 3. So you would have been there, and then you would have said that negative 1 plus 3 divided by 4 is 2 over 4, which is 1/2. And negative 1 minus 3 divided by 4 is negative 4 over 4, which is negative 1, which is those two right there. Okay? This, as an answer right here, that's a no-go. Okay? Because you can do that math. If there were a radical involved in there, yes, then you could give that as an answer. But because that's all nice, even, beautiful looking numbers, that's a no-go for an answer. Okay? You have to do the math to get those. Okay? Alright, so steps to finding rational zeros, or steps to finding all zeros, we could say. Okay? First off, you find the list. Okay? You narrow your field down to a certain amount. You find your list. Okay? Then, I told you that I would tell you the shortcut. Well, here's the shortcut. Step 2 here is the shortcut. The shortcut is you graph it. Okay? You graph it on a graphing utility. And you see where your graph crosses the x-axis. Okay? Now, you may be saying to yourself, Self, I don't have a graphing calculator. Yeah, you actually do. Because you have Desmos. Okay? You have the internet. There are, if you Google graphing utilities on the interwebs, you'll come up with a bunch of different sites that will let you graph them. The easiest one, the most user-friendly that we found, is Desmos. Okay? So if you go to the Desmos site, which most of you have used in a previous math class, okay, you can graph it right there on your Chromebook. Boom, there it is. Oh, okay. So then what's going to happen is you're going to look at where your graph, where your graph crosses the x, I didn't want to do that too either. Hit the wrong button. You're going to look at where your graph crosses the x-axis. So if it goes here and here and here, you're going to look at there, there, and there as your zeros. And if they're nice, easy numbers that are in your list, that's the ones you go to first, because those are the zeros of your function. Okay? If they're not nice and easy numbers, then you wait and you save those, because then that's probably going to be a quadratic formula at the end. Okay? But we'll get into that momentarily. Okay? Using synthetic division to divide out the zeros. Factor or use the quadratic formula to find the remaining ones, and boom, there we go. We're going to find all the zeros starting today. Okay? So, let's do that. Everybody got those written down? Anybody need more time to write those down? Okay? All right, so let's do this. Let's find all the zeros of this function. Okay? So, first off, I've got to make my list, because that was my first step yesterday. My first bus stop yesterday was make the list. So I'm looking at 42 here. 42 has factors of 1, 2, 3, 6, 7, 14, 21, and 42. How did I come up with those so quickly? Well, I knew 1, 2, 3, and 6, right? Because I knew 4 didn't go in there because of 40. And I knew 5 didn't go in there because it didn't end in a 5 or a 0. 6 times 7. But once you see that these two are right next to one another, once you cross over, because 6 times 7 is, then you just go backwards then. So 3 times what gets me 42? Well, that's 14. 2 times what gets me 42? Well, that's 21. 1 times what? Okay? These are all paired up. Those are all paired up. Those all multiply together to be 42. Okay? So once you find 1, you've really found 2. Okay? Then I got to find me factors of 2. And that's 1 and 2. So my list is 1, 2, 3, 6, 7, 14, 21, 42, 1/2. 2 divided by 2 is 1. Got it already. 3/2. 6 divided by 2 is 3. Got it already. 7/2. 14 divided by 2 is 7. Got it already. 21/2. 42 divided by 2 is 21. Got it already. Okay. So my list is still pretty long. Okay. There's 24 items still on my list. Okay. So we can utilize a graphing utility to shrink that list even further. Okay? Now I pre-planned and I graphed this function already. Okay? So I pre-planned this function already. So looking at the graph, I would say it crosses 4 times, right? So I'm going to have 4 zeros, which makes sense because the degree was 4. Okay? So it crosses here. Does that look like a nice 0? Not really. Okay? And really, these are all the only other zeros that we have that aren't whole numbers are halves, so they should be right in the middle of the two tick marks. Okay? This one looks pretty nice. What's that one going to be? What's that 0? -2. This one in here looks to be at the halfway point, right? Between 1 and 2. Well, what's that? What's the fraction that's halfway between 1 and 2? Number sense. What's the fraction between 1 and 2? 3/2. And then there's that one, and that one doesn't look nice because it's not at a halfway point. So if it were me, shortcutting it using a graphing utility, I would pick -2 first as my first 0 to try. 2, 5, -18, -19, and 42. Two, -4, 1, -2, -20, 40, 21, -42, 0. Okay? So f of x now is equal to x plus 2, because that's the factor if -2 is a 0, times 2x cubed plus x squared minus 20x plus 21. Agree? But that's an x cubed one yet. I can't quadratic formula that because it's not a quadratic yet. But I do know that I've got this possible 3/2 in there. So I'm going to try 3/2 as a 0. And I'm going to try 3/2 as a 0 in this polynomial. Because I don't want to do it in the original one, because that's just going to give me another cubic function. So if it's a 0 of the original function, it's going to be a 0 of this subfunction too. Okay? Alright? So try it in that one. 2, 1, -20, and positive 21. Drop the 2. 2 times 3/2 is 3. Add 4 times 3/2 is 6. -14 times 3/2 is -21. So it does end up being a 0. So now f of x can be written as x plus 3, or was it x plus 2? 2? X plus 2, my bad. X plus 2 times x minus 3/2 times 2x squared plus 4x minus 14. Can I factor a 2 out of this trinomial? Yeah, I can actually. Is that trinomial factorable? Two numbers that multiply together to be -7 and add to be positive 2. Nope. Only ones that multiply together to be 7 or 7 and 1. So that's a no-go. Okay? So then that means that x plus 2 is going to equal 0, which gives me that -2, 0 that I was at, or that I found on the graph. X minus 3/2 equals 0. That gives me the 3/2 that we had before. And x squared plus 2x minus 7 is equal to 0. So I've got the quadratic formula of that one. Plus minus square root of 2 squared minus 4 times 1 times 7. Oops, times -7, excuse me. All over 2. 4 times 1 times negative 7 is negative 28. 2 squared is 4. 4 minus negative 28 is 32. Oops, that's a bad 3. The square root of 32 simplifies to be 4 times the square root of 2. 16 and 2 there. Okay. All the outside numbers are even, so I can divide them all by 2, and that gives me x here is equal to negative 1 plus or minus 2 square roots of 2. So my zeros here, my 4 zeros of my function are negative 2, 3 halves, and negative 1 plus or minus 2 times the square root of 2. Moment to let that sink in. Okay. Ready to try one on your own? Go for it. So, my list is actually relatively short on this one. Plus minus 1, 5, and 25, right? So that's it for my list. Okay, all right, so now let's go to the shortcut. Shortcut tells me that I've got 2 real zeros. I got 1 here at negative 1. I got 1 here at positive 5. Okay? So let's do the negative 1 first. Now, if you did the 5 first, your numbers are going to be a little different in this first line. But they will be the same in the second one after I do the 5. It doesn't matter which order you do them in, but your numbers might look a little different in the middle. Okay? 1, 0, negative 16, negative 40, and negative 25. 1, negative 1, negative 1, 1, negative 15, 15, negative 25, 25, 0. Okay? So f of x from this point is x plus 1 times x cubed minus x squared minus 15x minus 25. Okay. Then we can do the 5. But I'm going to do it on 1, negative 1, negative 15, and negative 25. 1, 5, 4, 20, 5, 25, 0. So now f of x is x plus 1, x minus 5, and x squared plus 4x plus 5. Unfortunately, x squared plus 4x plus 5 is not factorable. I can see that x squared plus 4x plus 5 is not factorable in two spots. One, there's not two numbers that multiply together to be positive 5 and add to be positive 4. Two, I can look at the graph, and the graph doesn't cross anywhere else. Okay? So I know that these are going to give me imaginary solutions because I used up all of my zeros. X plus 1 equals 0 gives me x equals negative 1. X minus 5 equals 0 gives me x equals positive 5. X squared plus 4x plus 5 equals 0 gives me x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that is going to be negative 4 plus or minus 16 minus 20 is negative 4. Oops, missed. Square root of negative 4 is 2i. Again, bunny ears can be divided. So that would give me x here is equal to negative 2 plus or minus I. So my 4 zeros of this function are negative 1, 5, and negative 2 plus or minus I. Again, I remind you that tomorrow you need to bring your Chromebook and you need to bring your earbuds. You will watch a video and then you will have time to work on your homework. When you watch the video tomorrow, one of the things that I'm going to expect from you is I'm going to expect you to show some notes. So there might be, wink, wink, nudge, nudge, there might be a note check on Friday also. Or excuse me, on Monday when we come back also. Homework for today is this worksheet that I'm handing out right now. Okay. It will be due, it's one of the 4 things due on Monday.